Okay, everybody, here we go. We are starting our new PBL, and here we are, our project summary. So what I'm going to do is I'm going to talk a bit about the project that you need to generate when you get divided up into your group there. Now, right up here at the top, we have it highlighted, okay? Right there. That is the thing that you're going to be doing. You're going to choose an existing system, so it has to be real, like in the world. We're not talking like, you know, Starship Galactica kind of thing. No, sorry. Got to come up with a real system that actually exists, and you're going to become an expert on that system. All right? So, things that you should be able to do is determine the problems with that system that can occur within that system. You will design a physical model and a digital model. So down here in this section called deliverables, that right there, that's everything you need to turn in for a grade. Now, something that's included in this for a grade is the notebook that you got at your missions trip. Okay, so that one that you guys made in Miss Geisbush's classroom, that's part of this deal. You have to have that done and turned in for a grade. Now, things that we are going to be doing. You get the choice of making a physical model or an interactive trifold. You pick one. One will be made for your entire group. Okay? Now, the other thing is your digital model of your system. So each member of the group will make their own. You're going to have time in Miss Sampaio's class to make that model. However, you will be making your own. But you need to demonstrate your understanding of this system with that model. So that's kind of a test for each partner. If it's clear that one doesn't understand it, then one member of the group's grade is going to suffer. All right, there will also be a written report. Each member of the team will write their own report. There's requirements down below we're going to go over, okay? So everybody writes their own report. Then, together, as a group, you will give a presentation. Each member of the group will present part of this, okay? Now, the thing you need to be aware of is this note right down here. You're not only going to be asked questions about the part you talk about, you could be asked questions about the entire system or about other parts of the presentation. So you need to know what's going on. You can't just divide this up and be like, I'm never talking to my partner again. I'm just going to listen to them talk during the presentation and who cares? No, you need to do this as a team. So you need to be prepared for questions about what someone else talked about during your presentation, especially since we might be having some guests from the outside world talking here or watching your stuff here. So now we're going to talk about the model form requirements. Okay, this is the physical model that we're talking about first. Now, it must have these bolded things that we're going to talk about. Label the parts. Okay, make sure you have a key for those symbols that you're going to use. This is part of just good chart making, good model making. If you don't have labeled parts and easy to understand key of the symbols, it just doesn't make sense. All right, you need to demonstrate the input, the output, and the relationships between the parts. It needs to be so self-explanatory that somebody else who doesn't know about your system can look at it and understand it. Okay, so make sure that you are paying attention to that and that you get somebody to check, either me or one of the other teachers, or perhaps another student would be better if they don't know as much about it. Now, the model should be complete. If you're doing a grandfather clock as your system, don't show up without the clock mechanism parts that are laid out. Don't show up without a clock face. That's important, okay? Now, how the system works and should be obvious from looking at the model. I should be able to look at the model and see what's going on and understand how it works. It shouldn't be so convoluted or difficult to understand because it's messy or whatever that I can't understand it. So it should be obvious from just looking at it and seeing the labels how things work. Okay, find the scale factor. So your scale factor is going to be given to you in math, all right? And then you're going to need to do some work with that scale factor so that you can basically explain what your factor is in your model to the actual size thing, whether you scaled it down or scaled it up, depending on if you're looking at a jumbo jet as a scale or as a model, then you're going to be scaling down to your model. If you're looking at, I don't know, a human cell as a system, you're going to be scaling that up. So you need to think about what your scale factor is going to be in terms of that. All right, your digital model. Again, everybody's making their own. You're going to be using Tinkercad in Ms. Sampaio's class. So make sure that you are aware of how to use that and you're paying attention because it's going to matter for your grade. It's very, very similar to what we're doing above. Labeling the parts, making sure the input-output relationships and all that are clear and someone can easily understand that. The key to be obvious from looking at it is the same, okay? And the same issue applies to your scale factor. You need to be aware, okay, of what your scale factor is. Be prepared to explain that as part of your presentation. Now, if you choose to, rather than make a physical model, if you choose to do the interactive trifold, things can be a little bit different because some part of that trifold must be interactive. That means I come up as the viewer and I get to tinker and mess around with and play with and learn from doing something on your interactive trifold. Now, you have to think about this, that your display will receive many visitors. If you build this little fragile, thing, and first person visiting it breaks it, you're going to be underwhelming a lot of people. So make sure that you produce something that is quality, engineered well enough to survive. All right, label the parts. That's the same as all the other stuff. Demonstrate the input and output. That's the same as all the other requirements. How the system works being obvious is also the same, and the same issues with your scale factor. That should all be on your trifold presented there in your system. So if you're using a trifold to present your system, that's fine, but it needs to be obvious, and all the other categories must be, or bullet points in this case, must be taken care of. Now we move on to the report. Okay? Each part of your report must be labeled. Now, the parts of your report are right here. Okay? These things must be talked about or you're going to lose major points. So, list the parts of your system. Bullet points are fine. Explain what each does, the function. Okay? So make sure we understand from your report what each part does. Okay? It's been a long time since I studied some of this science stuff, since I've studied some of these things, so you need to explain that. Not to mention, I might not know much about jet engines, and if you're doing a jet engine as a system, you better be able to explain those parts that I don't know. All right, now, explain what things could go wrong. Okay, if you're doing that jet engine and a chicken goes through the engine, well, chickens don't fly. Anyway, if a chicken goes through the engine, that's going to cause some problems. Explain what could go wrong. Explain how that one thing that is changed could affect the entire system. So the idea there is that you are understanding how problems with one area impact others or changes in one area impact others. This is where you demonstrate that you understand the relationships in this system big time. All right, now, how the system can be improved. So the idea of improved, what does that mean? What kind of areas would you improve? And then how your solutions or improvements will impact the future. Because if you're talking about an engine or something like that, and you're talking about fuel efficiency, well, that has long-reaching things. If you get a car that can do 100 miles on a gallon of gas, whoa, the game has just changed. So that will have a historic impact. And that's what we're talking about next. Okay, what is the historical impact of your model? Again, if you're talking about something like an engine or an airplane or something like that, that has changed the world. So you need to speak about how it has done that. Historical impact, has that been positive or negative? This is where you need to do some research and think about the good and the bad, where you need to maybe make a judgment call. about whether you think it's been positive or negative. Okay? Then you have some math things that you need to do. You need to understand area and volume and their relationship, or about how they are affected by your scale factor. Okay, so that's something you would need to do also in your report. Okay, so this needs to be nice and organized and typed up so somebody can come and read it and get the gist of your system. Lastly, we have the presentation. Okay, your presentation of your projects, that's going to be on a date to be determined. We're still looking at the calendar, kind of tinkering with stuff to figure out when exactly we're going to do this, but you are going to be doing this either in the CLC or the classroom. Okay, so you understand where this is going to be happening. Now, your audience will include parents, high school STEM students, Nimitz faculty, district office personnel, and other outside stakeholders. So all kinds of people could be there. Engineers, doctors, lawyers, all kinds of people who know stuff about your system could be there to talk to you and ask you questions. So be prepared and be accurate. Now, when you are like the top presenters, if you're the winner out of the room, you go to the next round where you're evaluated by guests at a later date. So some guests will come in and be like, wow, this is the most impressive. So it gets a little bit kind of like a little bit like a science fair or history fair at this point, where somebody's being chosen to be like the winner. Now, model rubric is here. I'm not going to insult your intelligence and read this whole thing to you, but the idea there is that you want to be in this number 4 category. Okay, creative, complete, 100%. There are no spelling, capitalization, or grammar errors. You want to make sure you're there and not 3, 2, or 1. 1, you're going to kill your grade because we're talking about less than 50% of the model is according to scale. This could go bad, okay? Make sure you're at a good model. Now, presentation rubric. Scroll back down here, guys. So, same thing. 4 to 1, you want to be sure you're on the 4 side. When you're thinking about preparing your stuff, go through your rubrics. Pay attention to what's going on here. Make sure that you have all these things here. All right, now, report rubric, again, same grading scale. Make sure you are hitting the 4s. Go through the rubrics. Make sure you're preparing yourself for all of these pieces. Grade yourself. Grade another person's. Go through and use this to make sure you can make your project the best that you can. Okay, good luck, guys, and we'll be breaking you up into groups here soon and letting you know and giving you some time to work in class on this. So thank you very much. Good luck.